Naughty, naughty, Tyler. All right, here we go. Right hand, left hand, and trapezoidal sums. We read it like this. So, here's the deal. We're going to write some notation for right hand and left hand and trapezoidal sums. Okay? So this is summation notation using Riemann sums. We've written it before. You're going to see it later, and we'll explain what it all means. Okay? The idea is that we sum up the heights. Okay? And the way that you get the heights is you plug in your x value for the function. This means you just add them all up. But we also need to multiply by the width. Question is, how did we come up with the width? For example, see this one right here? You're going from 0 to 16. Okay? Suppose you're going from 0 to 16. Suppose that you had 32 rectangles. What would be the width of each rectangle? One half. What you did is you took the endpoint, which we'll call B, minus the beginning point, which we'll call A, and you divided it by the number of rectangles, right? So we'll add this to it. B minus A over N. Now this isn't notation that is 100% accurate for what they have with the book, but it's good enough for what we need to understand. The heights, the width, the sum. Here's the difference. If we do left hand, we still have the same width, but the difference is instead of starting with k equals 1, we start with k is equal to 0. And instead of going to n, we go to n minus 1. And I'll show you why that is in a second. Those are both rectangles. I showed you right here. Can you see the two rectangles I have here? One underestimates, one overestimates. And when I averaged them, what shape did it make? Yeah, it just makes a trapezoid. So all we have to do is, if you want the trapezoidal sum, I won't write it all out. Just left-hand sum plus right-hand sum divided by 2. It's your trapezoidal sum. That's it. Let's draw it out so we can understand exactly what's happening. Okay. We have a function. We're going to start the boundary of A and B. And we're going to divide it up into a certain number of rectangles, okay? And I'm going to start with the right hand because that's what we talked about the other day. I'm going to divide it up into just 4 pieces here, okay? And if I draw the right-hand sum, it's going to look like the black part. Okay, so this is the important part, guys. When I actually go to find the height of this rectangle, Do I plug in the number on the right or the number on the left? I plug in the number on the right. And so we end up starting really with the height of the number 1 rectangle, and then the number 2 rectangle, the number 3 rectangle, and the height of the number 4 rectangle. So 1, 2, 3, 4 aren't necessarily positions. They aren't x values necessarily. That's the rectangle number, okay? Watch what happens if I do the red. Now I have that height. Is that a new height? Or is it the same height as we had before? It's a new height. We'll call it the height of the number 0 rectangle. Am I doing the right hand side or the left hand side now? Now I'm doing the left hand side. Now watch this. When I do the next rectangle, is that a new height or is it the same height? It's the same height as which one? It's the same height as rectangle 1, isn't it? And then when I do 2, is that the same height or new height? Same. That's from rectangle 2. And then the same, that's from rectangle 3. So do you see that for the left hand, I go 0, 1, 2, 3, but for the right hand, I go 1, 2, 3, 4. See the difference? And if I simply averaged them, I would get, do you see how much of a better estimation? That was great. Do it again. Who was it? Do it again, please. Okay, all right. Warn us next time so we can get it on tape. Yeah. So you see how the trapezoidal sum is a really, really good estimation, don't you? When we do the problem today, problem number 1 right here, please, everybody, keep this picture in mind. When we add up an infinite number tomorrow, you're going to want to keep this picture in mind. It's so important. I know you all know how to add up the area of rectangles. It's kind of the summation piece as you understand which ones we're choosing that is so important. So let's now do this part. We're going to use our calculator. Make sure your calculator is out. We're now going to do right hand sum, we're going to do left hand sum, and we're going to do trapezoidal sum. We just have to make sure we set it up correctly, okay? We're going to do 8 rectangles. You don't have to write the sigma notation at all. You can simply write what we're going to put in our calculator. We are going to first do the right hand sum. Right hand sum. I first need to find my width. My width is, and I'm going to write it out. I know that you can all see it, but I'm going to write it out because we're going to use this tomorrow. 4 minus 0 divided by 8. times, so which is 1/2 times the sum of what? What did we do yesterday? Sequence of y sub 1, which is square root of x, comma, x, comma. All right. What is the first point at which we evaluate the height of the triangle? 0.5. What is the last height? 4. What is our width each time? 0.5. Let's do it. Stupid calculator. Okay. 0.5. Second, catalog. If I go to T, I could go up at sum, catalog. S for sequence. Now what? Bars, y bars, function, y1, comma, x, comma, 0.5, comma, 4, comma, 0.5, close. Got it. 5.765. Everybody get it? Shh, don't clear it. Don't clear it. Okay, keep it there. Now, if you're doing the left-hand sum, my width is still 4 minus 0 divided by 8 times the sum of the sequence of y1, comma, x, comma. If we're doing the left-hand sum, where do we start our evaluation point? 0. So your first one, as you see, has a height of 0. And then, so you'll be doing the red ones. What is, so we start, so this is 0, comma, what's our last spot? 3.5. One back, right? Do you see the difference? The only thing that changes is your start and your end. That's it. So, if I take my calculator and I go second entry, it will grab the same piece. Instead of 0.5, I just go 0, comma, 3.5. comma, 0.5, parentheses. That way I've got it all sorted through. 4.765. I'm hearing some, are there questions out there? What's going on? Oh, everybody, look at your function. Did you change your function? Make sure you put that in, okay? So, I had right-hand sum, I had left-hand sum. How do I do trapezoidal sum? 5.265. Well, let's look to see how close that really is. You remember yesterday I said you could go second, calculate. Which one? 7. And what's our lower limit for this problem? 0. What's our upper limit? 4. And it will do the rectangles for you. And 5 points. So we're pretty close, right? Pretty close. No. You are seeing that a lot of times you end up with a divided by 3. You'll see why. You'll see partly why tomorrow, and then next week you'll see the whole piece. All I want you to do is I now want you don't have to do anything by hand. For your work, because you're going to have to do this on the test. You have to write down the right-hand sum, left-hand sum, and the trapezoidal sum. You have to write down these pieces. That's your work. We have to see what you started with for your start point and your end point. Okay? That's what I need to see from you. Understand, I don't want to waste time by adding these all up by hand, or would you prefer to do that? That's what I did when I was in college. We did them all by hand. Right, this is dumb. We know how to do it already. They were just trying to make a point. I get it now, but that's it. Can you do it? This is your homework. Do you have the rest of the hour to work? I would like you to work on that. Yep.